Good morning, students. Today we will discuss about basic of CNC programming. At the end of this course, you will learn how to program in CNC for lathe and milling machine. Let's start. CNC stands for Computer Numerical Control. It is a method to operate machines through codes. The codes required is in the form of program called a CNC program. These programs are used to translate to machines by means of signal. The figure shows an overview of CNC. Programming CNC. To program a CNC machine tool, the series of steps given should be followed. Number 1. Examine the part drawing thoroughly and get a rough idea of how to proceed. Number 2. Figure out how to hold the raw material, so that it can perform as much machining as possible in one setup. Number 3. Decide what cutters are necessary to perform the various operations. Number 4. Write down the exact sequence of operations necessary to machine the part, one cutter at a time. Number 5. Convert the sequence of operations into a program, and simulate the program if possible. Important things in programming. To program a CNC machine, the first thing required is coordinate system. This is used to locate the tool, based on reference axis. The next is units. The program has have metric unit, or imperial unit. Next is positioning. The program should have absolute or relative positioning system. A machine has 6 coordinates, which are x, y, z, rotation in x, rotation in y and rotation in z. Next is feed rate and spindle speed. The spindle speed is used to specify the speed the chuck will rotate. Feed rate indicate removal of material. Next is coolant, and the last is tool parameters. CNC programming. Programming consists of a series of instructions in form of letter codes. We call this as preparatory codes. The first one is G codes. It is also called as general code, or geometric code. It is used for initial machining setup, and establishing operating conditions. Next is N codes. It specifies program line number to be executed by the MCU. Next is axis codes. It is specified as X, Y, Z to specify motion of the tool. Next is feed and speed codes. Feed is denoted as F and speed is denoted as S. To specify feed and spindle speed respectively. Next is tool codes. It is denoted as T to specify tool number. A CNC machine is a series of slots with different tools. Each tool can be chosen by tool number. Last is miscellaneous codes. It is denoted as M codes. Used for coolant control and other activities. The following are the key letters used in program. Just have a glance. Coordinate system for lathe. For turning machines, there are only 2 axes. So these machines are also called as 2-axis machines. The first axis is Z-axis. Z-axis is always the axis which has rotation. Here the chuck in lathe will have rotation. So the Z-axis is as indicated in the figure. The other axis is x-axis. The values in x-axis should be based on diameter value. The figure shows the top view of the machine with its coordinate system. Let us consider an example. For a workpiece, if we want to reduce the length of the workpiece, the values should be given in negative z-axis. Similarly, if we want to reduce the diameter, the values should be given in x-axis. Note there is no negative x values. X values should be given based on the diameter, not in terms of radius. Coordinate system for milling machine. The table will have x and y axis. Again, the rotation is in milling tool, so it is z-axis. To give depth of cut, we have to specify negative value in z-axis. Program syntax. The following are the sequence of format used as a program. First is sequence no. It is denoted as N codes. It is usually used in NC machines. For CNC machine it is not required, as there is flexibility in the software to insert the program anytime. Next is preparatory function. This is indicated in G codes. It is used to tell the machine how to move the tool. Next is destination coordinates. It tells the machine where to move the tool and its location. Next is used to indicate the radius or center of circle. Next indicates the feed rate of machining. It is denoted in F. Next indicates the spindle speed, denoted as S. Next is tool. It instructs the machine which tool is to be taken. The last is miscellaneous function like coolant on. Overall, this is the format of the program. Note that there is no need to repeat codes until it is needed to be changed. Example, if feed rate is constant, then it can be specified at the beginning of the code, and it is not necessary to repeat for other lines. Important G codes. G00. It means rapid movement of tool. G01. It means machining in a straight line. G02. It means machining in a circular path in clockwise direction. G03. It means machining in a circular path in anti-clockwise direction. Other G codes. As discussed in previous slide, the other codes are G20. It means programming in inches. G21. It means programming in millimeter. G28. It means home or reference position of the tool. G74. It is for peck drilling operation. G75. It is for normal drilling operation. G76. For thread cutting. G81. Used for drilling cycle, that is continuous drilling operation. G90. It is used in two syntax, one is for absolute coordinate system and other ID for canned cycle. G91. It is used for relative or incremental coordinate system. G94. It is also used on canned cycle but for facing operation. G98. It is used for feed in millimeter per minute. G99. It is used for feed in millimeter per revolution. There are other codes also, but for basics it is enough to know these codes. Important M codes. M00. It is used to stop the program. M03. It is used to start the spindle. This code should be used with spindle speed. M04. It is used to reverse the spindle. M05. It is used to stop the spindle. M06. This code is used to change the tool. M08 and M09. It is used for coolant on and off. M30. It is used to end the program. For additional codes you can refer the link given. The syntax for G01 is given. Here xn indicates the coordinate of the cutter in x-axis, zn indicates the depth of cut and fn indicates the feed rate. For example, let us use the code G01x10F15. It says that the tool is to move in positive x-axis for 10 mm and the feed rate is 15 mm per minute. For this code the tool will move from position 1 to position 2. The movement is shown. For code G01Z10, the tool will move only in Z direction, from position 2 to position 3. For G01x-5, the tool will move in negative x-axis, from position 3 to position 4. For G01x5Z5, the tool will move simultaneously in X and Z direction, from position 4 to position 5. Note: the entered program is based on relative coordinate system. The syntax for G02 is given. Here there is additional value r, which indicates the radius of the circle. The values of xn and zn should to the end point of the circle. Example: consider the code G02x5Z5R5F15. Here the tool will move as shown in figure. X5 is the end X position of the tool, Z5 is the end Z position of the tool and R5 is the radius of circular arc is 5 mm. The syntax is same for G03 except the tool movement will be in anti-clockwise direction. Note the program is based on relative coordinates. Absolute coordinate system. It means that the distances should always be considered from a fixed datum coordinate. Let us consider an example. In the figure, if the tool is to move from datum position to position A, the distance is 80 mm. If the tool has to move from A to position B, the distance is 100 mm. Note the distance is always calculated from the datum point. Relative or incremental coordinate system. It means that the distances should always be considered from tool's last location. Let us consider an example. In the figure, if the tool is to move from datum position to position A, the distance is 80 mm. If the tool has to move from A to position B, the distance is 20 mm, because the distance is calculated from the new position of the tool. Note the distance is always calculated from the tool position. G-codes for milling. There is no much changes in the syntax, except the coordinates r x and y z axis is used for depth of cut. Positive value in Z will be away from workpiece and negative value will be cutting the workpiece. Let us see an example of tool movement in milling. Consider the figure shown. The coordinates is mentioned. To move the tool from first position to second position, the code used is G01X30Y30Z-5F15. Here G01 is used to move the tool in linear motion. X30Y30 indicates the tool end position at 30, 30. Z-5 indicates 5 mm depth of cut. And F15 indicates feed rate. The tool will move from position 1 to 2 as shown. Next is G01X130Y60. The tool will move from position 2 to 3. G01Y80. Tool moves from 3 to 4. G01X100. Tool moves from 4 to 5. For the next position, there is a circular arc. To reach the next position, the tool will move circularly in anti-clockwise direction. So, the code is G03X50Y80R25. Here R25 indicates the radius of the arc. The tool moves from 5 to 6. G01X30. Tool moves from 6 to 7. G01Y30. Tool moves from position 7 to position 2. Note the code is written in absolute coordinate system. Program layout. To program in CNC. First thing we need is what is the units we are going to use for the program and how to move the tool, either in absolute coordinate or relative coordinate. For this we use G21 G90. G21 refers the program is to be in millimeter, and G90 refers using absolute coordinate system. The next line is the tool's home position. For this the code is G28U0W0. We use U and W, which refers X and Z coordinates, respectively. If we have Y coordinate, we have V0 also in the program. The next line is feed rate unit. For this the code is G98. It refers to feed rate in millimeter per minute. The next line is to choose the tool. The code used is M06T01. Here T01 refers to take first tool in the tool post. Next line is to start the spindle. The code here is M03S1200. It says to rotate the spindle at 1200 RPM. The next lines will be the tool path program. At the end we use G28U0W0. Moving the tool to home position. M05. Stopping the spindle, and M30, ending the program. This is the overall program layout. The first 5 lines is the header of the program. Middle portion is the tool movement program, and the last 3 lines is the footer of the program. Let us consider a problem shown. The movement of the tool is based on the code given below. Here we use G91 to change the coordinate from absolute to relative, as it is easy to program.